Hi, I'm Mark Ryan. In this video, I'll take you through an example of using callbacks to get the most out of the training cycle for your fastai deep learning models. The examples in this video are also featured in my upcoming book from Pact Publishing, Deep Learning with FastAI Cookbook. In FastAI, callbacks let you control the operation of the training loop. The framework supports a very broad array of callbacks that let you control many aspects of FastAI. In my book, Deep Learning with FastAI Cookbook, I describe how to create callbacks for the following 4 situations. Train a model in mixed precision, which can be essential to save memory in the training process. Display graphs that show details of the training process, such as validation and training loss. Stop the training process when it stops improving for the metric that you want to optimize for, such as accuracy. This is called an early stopping callback. Save the best model from your training process. This is called a model save callback. In this video, we will look at how to create callbacks to implement early stopping and model save callbacks in FastAI. These 2 callbacks are particularly important because they help you to ensure that you get the most out of the training process. In addition to digging into these 2 FastAI callbacks, we'll also look at how they compare to similar callbacks in Keras. We're going to run one of the examples from the book, and this one is in Chapter 8. It involves training with a tabular data set, and the data set is the adult sample data set. So there's the statement right here, which pulls this data set into a data frame. And then here we take a look at what's in the data set. It's a set of characteristics of individuals, their education, the number of years they've had in education, their marital status, their occupation. And the purpose of the model is to predict whether or not the person has an income greater than or less than 50K. So we've run the first few cells here. And what we're going to do is get down here. So we've defined a data loaders object. And we're going to go through and define the actual model 3 times. Once with no callbacks, once with only an early stopping callback, and once with both an early stopping and model save callback. So let's go ahead and see what happens. So now we're training the model with no callbacks, and we've set a run of 10 epochs. So what we expect to see is it's going to run through each of the 10 epochs. Start off with decent accuracy. It'll go through, get loss and accuracy for each of the epochs, and it's going to execute each of the 10 epochs. That is, it's not going to stop until every epoch is run. And we'll see a couple of things here. One is that we're probably not going to get the optimal result at the end, and we're going to keep going when things are not getting any better. So there you saw in epoch number 2, we get accuracy of 0.86, and now the accuracy has gotten a bit worse, and it's not getting better. It's going to keep on running right out to 10 epochs. Still not getting better. And I'm actually paying for this. This is a 4-pay gradient notebook. So it's costing me about 50 cents an hour. So every minute that these epochs are running, it's costing me some. And the fact that the accuracy is not getting any better means that I'm sort of throwing money down the drain. It's not much money, but it's something. And we get to the final epoch. Okay, there we go, a little over a minute. And as you can see, we got accuracy of 0.86 in epoch number 2. The final accuracy is 0.84. And if we run validate, there we see 0.84. So 2 things wrong with this run. One is it kept going after the accuracy was no longer improving. So we're wasting money, wasting resources. The second is that the model I get at the end has less, it has whatever I ended up with in the final epoch, as opposed to the best accuracy during the run. So here we're going to create the model again and train it again, but this time we have an early stopping callback. So let's see what happens. One of the things I should mention here is I've set a common seed, and that means that we should get consistent results for each of the epochs between runs. And the book describes in detail how to set that common seed so you can do experiments like this and compare one run with another. So I think remember it was epoch number 2. We got a 0.86 accuracy. There we go. Now, one of the things that's set here is patience 3, which means that it's going to give it a little bit of time to get better. So it's not going to, it shouldn't run to the end of all 10 epochs, but it's also going to give the training process patience of 3, which means it'll try for 3 epochs to get better. And if it doesn't, then it should stop. And there, as we expected, so we had a high water mark in epoch 2 of 0.86. It didn't get any better. And so it stopped early after the 5th epoch. And let's see, what's actually we get at the end? It's 0.83. So this is somewhat better. We're not wasting extra time on the running of the training. However, we're still not getting the optimal accuracy from the training run. So let's try it one more time. And this time we're going to have both callbacks, early stop, and save model. And let's see what happens. The training again, here it goes. Now we should see again in epoch number 2, accuracy of 0.86. The patience is still 3, so it should stop 3 epochs after getting 0.86 when the accuracy no longer improves. And what we will be looking for is the model that's saved. Does it have an accuracy of 0.86 or whatever the terminal accuracy is for the last epoch that was run? And it should go for one more epoch now. Okay, so it stopped again after 3 epochs after the high water mark. Now let's check and see what the accuracy is after the whole process. And here you can see the accuracy is 0.86. So with 2 callbacks, one for early stopping and one for model save, we get the best of both worlds. That is, we're not wasting resources doing training epochs when the metric we want to optimize for isn't getting any better. And when the training run is all done, we end up with the optimal, we end up with model with the optimal metric for what we want to capture, in this case, accuracy. Okay, now that we've seen the impact of these callbacks, let's take a little bit closer look at the syntax for defining them. So in the fit statement here, there is a list created of the callbacks that I want to establish. So I define one for early stopping. It has a parameter monitor accuracy, so that's what I want this callback to be measured on. I have a parameter min delta, that is how much change I'm going to care about from epoch to epoch, and then patience. And again, the purpose of patience is to determine how many epochs the callback is going to let go by before it notices that the metric I care about is no longer improving and it shuts down, it stops the training process. And for save model, similarly, this is how I define the save model callback. And I specify what I'm monitoring, accuracy, as well as the minimum delta. That is the difference that I'm looking for. And that's all I have to do. So defining these callbacks in fastai is pretty simple. They're just parameters for the fit statement. It was quite intuitive for creating them. And if you want multiple callbacks, you can just create a list of them and everything works. Now let's compare what it would look like to define early stopping and a model save callbacks. Essentially do the same thing that we just did in fastai. How would we define them in Keras? And it's a little bit more complex. So here I create an instance, an early stopping object. I specify what I want to monitor, and ES monitor is defined to be accuracy. The mode, so here I can specify whether I'm looking for it to increase or decrease. I also specify the patience. So that's for early stopping. And then down here, model checkpoint, this is to save the model. I specify a path. I specify what I want to monitor. I specify whether I want that metric to be monitored for going getting larger or smaller, and there's a flag to save only the best being true. I append these to a list, and then this list is used when I do the fit statement. So if I go down here, and if I say here I want to do early stop, so in the fit statement here, I include the list that I defined in the above function, callback list. So it's a little bit more complicated. There are a few more parameters that need to be specified than fastai, but it's similar. In fact, the experience, if you've used Keras callbacks, then you'll find fastai callbacks pretty easy to use. And that's a summary of how to use fastai callbacks to optimize the training process. Thanks for watching, and don't forget to like, comment, and subscribe.